Hello, everybody. Happy Wednesday. Okay, so let's just recap a little bit here. So yesterday, you should have watched the video lesson on isosceles and equilateral triangles and worked on the worksheet. I hope you held on to them. In case you have questions, we can go over that stuff tomorrow when I'm back. And then today, we are doing a video lesson on triangles and coordinate proofs. That will be linked here when I'm done recording, and then you're going to work on the worksheet. So kind of like a normal day without me being there. So we'll pull up the notes here. Sorry, folks. Let me get there. Okay, so let me just preface that this lesson might be a little bit longer than normal, because I'm going to just try to talk you through things slowly, and I hope that you understand them. It's really not that complicated. It's just one of those things that since you've never done it before, it's hard. But right, if you kept doing the same thing over and over, day after day, it gets easier, right? Well, we're just starting at day one today. So know that you might be kind of confused, but so is everybody else, and it'll be okay. So prior to today, you were doing proofs on a specific triangle, right? A triangle ABC is congruent to triangle DEF. You got to show those two specific triangles were congruent. Now we're going to take the specificness out of it and prove certain things about, like certain properties about triangles are true. So when you have something that's more general like that, it's all like kind of vague, and we use variables. And you'll see what I mean in a moment here, but we're just trying to be more vague so it's true for every single triangle that fits this criteria, okay? So we have some tips and tricks that will help us do these sorts of proofs. So here we go. Coordinate proofs use figures in the coordinate plane and algebra to prove geometric concepts. The first step in a coordinate proof is placing the figure on the coordinate plane. So here are some things that you should always consider while placing your figure on the coordinate plane. We want to use the origin as a vertex or the center of the triangle. So that just makes for easy computations with the point 0, 0. Remember, the origin is 0, 0. Place at least one side of the triangle or figure on an axis. Again, that just makes for easy computations because one of your coordinates, the x or y, will be 0. Keep the triangle within the first quadrant. Again, you're thinking of your future self, what's going to make your math later on easier. Well, if we're in the first quadrant, remember that's this quadrant here. Everything's positive. Your x is positive, and so is your y. And use coordinates that make your computations as simple as possible. What does that mean? Like for me, if I can avoid a fraction at all costs, I'm going to manipulate the coordinates in my benefit for that. I'm going to try to use even numbers or something, so when I divide by 2, I get a whole number instead of a fraction. So let's try label these two random triangles in the coordinate plane. So this is what I'm saying by it's more general, right? We just have a triangle. It's just a general triangle. We know nothing really else about it, okay? So we'll notice that it's in the first quadrant, so that's taken care of here. We see that one of our vertices is at the origin, so that one's 0, 0. And then we have one side along the x-axis, which again, you guys, makes it easy to compute length, right? Because I went over, well, do we know how far we went over? No, so I'm just going to give it a variable. I'm just going to say we went over amount of A. But then how far up did we go? 0. So we for sure know it's 0, which again will help us later on when we plug into like the distance formula or the slope formula. Now for this last vertice up here, I don't know how far over I am, right? I have no idea. I just know it's not A and I know it's not 0. So I'm just going to call it B. And I don't know how high I went up, so we're just going to give it another random variable, so C. So kind of goofy since we're not using numbers, and it's just because we're keeping it vague. We're keeping it like we don't specifically know that this side length is 7 units long. We're just keeping it very vague and very general. Okay, now let's try it with a more specific kind of triangle, an isosceles triangle. Right now your brain should be thinking, well, what do I know about an isosceles triangle? Well, I know that my legs are the same length, right? They're congruent. So that will kind of help us with our ordered pairs if we consider that fact that we know the legs of an isosceles triangle are the same length. So let's start with the easy one. And that's kind of like the rule today, you guys. Do what you can. Start with what you know. Well, we all know where the origin is. That's 0, 0. All right, let's move over. So if I come over here, well, I don't know how far over I went, so I could call it A. And I went up 0. Now for this vertex angle spot here, right, that last vertice, some things that we know about an isosceles triangle, that it's directly in the middle of this side length. So if this whole side length is A, what would the midpoint be, right? It'd be half of A. So this is where you want to pick coordinates that kind of make your life easier. So instead of making this A, I'm going to make it 2A. And I'll explain why in just a second. So if this whole length is 2A, halfway through it would just be a single A, right? So that would be A and this would be A, which makes finding out this part here A, and up, we don't know how high up we went, so we'll say B. So that's something to consider when you're making your ordered pairs. If you don't want to work in fractions, sometimes it's in your benefit to like double one of your variables. So if you know you're cutting it in half, so you have a whole number instead of a fraction there. But at the end of the day, your math will still work out. It just might be more messy than this. Okay, so now we have an idea how you label these triangle coordinates. Now let's talk about like what are some strategies to help you solve these proofs. Well, how do you solve or how do you show segments are congruent? Well, congruent means the same length, right? Which means what? Their distances are the same. So if you want to show segments are the same length, you would have to use the distance formula. So here we go. Write this down. Or it's on the board, I suppose. So you'll be using the distance formula a bit today, but you guys are all very good at that. We're just using it with variables instead of numbers. How do you show that lines are parallel or perpendicular? I'm hoping you're thinking slope. Let's just kind of review. If they're parallel, they're the same slope. And if they're perpendicular, they're opposite reciprocals. Quick example, right? That would be like if you had a slope of 3/4, its opposite reciprocal would be negative 4/3. Let's jot down the slope formula just so we have that and remember what that looks like. You subtract your y coordinates all over your x coordinates. Okay, so step 1 is drawing your triangle. Step 2 would be figuring out how are you going to prove what they're asking, and it's probably either going to be with the distance formula or the slope formula. So let's try one of these, okay? It says the medians drawn to the congruent sides of an isosceles triangle are congruent. Okay, before we even get into what that question's even asking, we know we have an isosceles triangle. So I'm going to draw our triangle in the first quadrant. That is step 1. You might want to make your picture a little bigger just so it kind of is easier to understand. So I know I'm in quadrant 1. And we're going to draw our triangle here. Try to be as neat as possible. We'll label those second. So that is our isosceles triangle. Now we want to show that the medians drawn to the congruent sides of an isosceles triangle are congruent. So again, this is where proofs get kind of tricky, right? Because you've only been in geometry for X amount of months, so some of you might not know what a median is. Well, a median is a segment that goes from one vertex to the midpoint of the opposite side. So that's a median, and here's a median. And we know that that's the midpoint, that side, and that's the midpoint of this side. Okay, so far this is what your picture should look like. Our end goal is to show that this green and red segment are the same length, but we'll talk about that in a second, because now we're going to go back and label all of our ordered pairs. So let's first just give them letters so we all know what we're talking about. So I'm just going to go around my triangle and label them A, B, C, D, E. Again, all I'm asking for you to do today is what you can. You all know where A is. It's at 0, 0. And from here, it really gets kind of hairy because you could do it your own way, or you could follow me and do it how I label it. I'm going to show you how I would do it. So I'm noticing for me, since I know this is isosceles, that point C is halfway between A and E. And then I know that B is halfway between A and the midpoint of this side. So really, if I think about this, I'm kind of sectioning off this bottom side in congruent force. So really, for me, I'm thinking E, let's say it's 4A away and up 0. And it will make sense why I'm doing that in a moment, okay? Because now I know C is halfway between A and E, so what's half of 4A? That's 2A. And I don't know how high up it went, right? I have no idea what this value is up here, but I know that point B is halfway between C and the x-axis, so whatever I put, I'm going to want to double it. So instead of just putting a B, I'm going to put 2B. Okay. Now if I look here for point B, I went over 1A away, right? These are all little a's. Went over 1A, and then this would be a B, and that's a length of B. So this ordered pair would be over A up B. Now if we look at where D is located, how many A's away am I from the origin? Well, there's 1, 2, I'm 3 A's away. And how far up? I'm over B. And you guys, I'm really sorry if this is confusing. This is a tough lesson to do on a video, so I can't gauge your faces on if we're getting it or not. But again, do what you can today and at least get your notes down so we have something to look back on when I come back. All right, so now that we've done kind of, I think, the most complicated piece, what we want to show now, I write this down. We want to show that AD is congruent to BE. So now you're thinking, well, how do I show two segments are congruent, the same length? That's right here. We're going to use the distance formula. So let's start off by finding the distance from A to D. So give yourself a big square root. All right, so we're going to take our x coordinates and subtract them. So here's x1, y1, x2, y2. Here we go. 3a minus my other x coordinate squared plus b minus our other y coordinate squared. So you can plug in. That was pretty straightforward. Now we're going to simplify. What's 3a minus 0? Let's just simply 3a. B minus 0 is just b. And now we got a square. So So remember when you're squaring a quantity, so something in parentheses, you got to distribute your exponent. So 3 squared we know is 9, a squared, and b squared would be b squared. Now for the purpose of us, that is it. We just found the distance of AD to be this guy right here, okay? So now if we did everything right, when we find the distance of BE, we should hopefully end up with this exact same expression. So let's try that out. Maybe this would be a good time for you to challenge yourself and plug into the distance formula on your own. But if you don't think you're there yet, that's okay. You can follow along with me. I do x1, y1, x2, y2. Here we go. So I'm going to take my x coordinates and subtract. So 4a minus a squared plus 0 minus b squared. And all we did was plug into the distance formula. Now we're going to simplify. 4a minus a, 3a squared. Hey, that looks familiar. That feels good, right? That feels good. 0 minus b is just negative b squared. Now we're going to square these. Again, distribute your squared. So 3 squared is 9. A squared is just a squared plus. Now negative b squared, that's negative b times negative b, which is b squared. It's a positive b squared. So folks, I'm hoping you're seeing something, right? Did we get the same thing? Heck yeah, we did. This is the same as this. So we did just, in fact, you guys show that AD is congruent to BE because they are the same. Woohoo! Now, I know that was probably super confusing, but don't tell me it's not a little exciting that we were just able to do that, right? That was some top level brain activity happening there. So I know you're so excited, let's flip it over and try another one, okay? All right, let's read it, see what it's asking of us. The line segment joining the midpoints of two sides of a triangle is parallel to the third side. Okay, so besides the fact that we just have a triangle and there's going to be midpoints on two of the sides, that's about all we know. It's not isosceles, it's not a right triangle. So again, it's just very vague. Let's start off by drawing your first quadrant. And we know we're going to have one vertex here. Again, this is some arbitrary triangle. We don't know what it looks like. Here's another one. Here's another one. Connect our dots. So we have one vertex at the origin, one side on the x-axis. Okay. So we can pick any two sides, but for me, I'm probably going to use the one side on the x-axis here, being the side I'm going to show that it's parallel to the side that we're creating. So I'm going to put a midpoint here, so I know that this piece is congruent to that piece, and a midpoint here, so those two chunks are next to each other. And again, you'll see why in a moment why I'm showing you that. So when we pick our vertices, it kind of makes sense. So here's A, B, C, D, and E. Well, we all know where A's at. That's at 0, 0. Now B, let me change up our colors here. Oops, here we go. Now B, we don't know how far over we went, so I'm just going to call it A. And I don't know how high up I went, so I'm going to call it B. But now since B is the midpoint of point C here, I know that this has to be another A over and 2B up. So that's going to be 2A, 2B. Now when we look at E, since we don't know it's an isosceles triangle, we can't say that E is 3A over. It would be nice if it was, but we don't know what this green distance is. We have no idea. So we're just going to call it C. We're just introducing another variable. So I'm over C, but I'm up the same distance as B, so I'm at B. And now for E, we got to be 2 C's away, right? If D's the midpoint, we have to keep that distance the same. So it'd be, hold on, we got to do a little shimmy here so this makes sense to you. So we know, okay, this distance here is 2C. And this distance here, hold on one folks, this red distance, how far is C over is 2A. So together for point E, we would have to add them. So 2A plus 2C and up 0. So kind of hairy, I know. But again, we're just trying our best here, folks. Now maybe get rid of some of my lines. Okay, now we can try to figure out what are we exactly trying to do. We want to try to show that if I connect these two midpoints here, that segment is parallel to this third side here. Okay, so we want to show, I would write this down, show BD is parallel to AE. So since we're talking about lines being parallel, right, we're going to use slope. So let's first find the slope of AB. So here we go. Here's your x1, y1, x2, y2. So we're going to have your y coordinates subtracted from each other over 2a plus 2c minus 0. We simplify, 0 minus 0 is 0. 2a plus 2c minus 0 is just 2a plus 2c. Being the brilliant mathematicians that you are, what's 0 divided by anything? Just 0. And it should make sense, right? We drew it on the x-axis, which is a horizontal line, so that should have a slope of 0. Okay, now let's try finding the slope of BD. So if we look here, x1, y1, x2, y2. There we go. So if we take our y coordinates and subtract, we're going to have b minus b all over c minus a. E minus b is 0. C minus a, it would just be c minus a. 0 divided by anything, folks, is a goose egg. So look at us. We got the same. It was kind of ugly to get there, but we did it. But since their slopes are the same, they are indeed parallel. Okay, don't turn me off quite yet. I just have a few more things to say, and I'm sorry I'm probably putting you to sleep. But thank you for watching this, and I hope you absorbed at least something. But it would be a great time right now for you to pause the video, go show Mrs. Kohlmeyer or Miss Dittis your notes to get your worksheet, and I will help you maybe set up the proof problems so that you can have a chance of solving them on your own. So if you want to pause the video, actually, you know what? Pause this, and I'm going to make another video of the worksheet, okay? So this video is done. Get your worksheet, and if you need help on your worksheet, I will make a video with some helpful tips on that next.